and you're only paying for those milliseconds that you use. This allows us to provide a minimal glue that allows you to stitch all of Firebase's products together. So, I mentioned event-driven. So what this is you actually write snippets of code that listen to an event. This is Node.js code. Those functions are each isolated. They're all running separately, so if one of them crashes, it doesn't take down the other. And when those events come in through PubSub, it will execute that code, and it'll either write back to the database or trigger some other action. So you can do things like listen to a database write. Then the code can sanitize the input and write to another spot on the database. So let's see this in action. All right, so here's a very minimal example. This is probably the basis example. Every time you see something, we have a hello world function here. So this is an HTTP function. This allows us to spin up an API. So this HTTP function is actually in the Express.js style. And then it sends hello world. So this is an HTTP request. It is synchronous. We don't want to be doing async work on this. We want to send a response as quick as we can. So let's jump to a more complicated example. So here's one where we're actually listening to the database. So up here, we're actually initializing Firebase functions and the admin SDK for Firebase. We're pulling in the configuration and initializing Firebase admin. We're then listening on the database, this ref, and those are wildcards. Those will be parsed into our parameters. And then on create means it's a database insert rather than an update or destroy. It sends an event object. We pull the current value. We pull the username from that, the text, title body, and we send it to the room ID on an FCM topic. So what does this do? When a message is posted to a chat room, it will notify through FCM, push notifications, all subscribers. Regardless of platform, right? This could be iOS, this could be Android, this could be the web. And magically, they're going to get this. And very little code. We run this. This is an independent function. We just deploy this. And Google is going to handle all of the scaling up and scaling down as needed. So, what type of things do we have? You already saw the HTTPS function. That allows you to send an Express.js response. This Express.js object, it doesn't have to be as simple as just that response send. You can actually create an Express.js application. It could be your full JSON API. So where I had that hello world, that will match any path on there. So you could just have exports API and then give it an Express application that has your entire JSON API. There's also Cloud PubSub triggers. So Cloud PubSub allows you to do durable publish and subscribe. This would allow you to take, if you do have a server, you could actually be writing to a PubSub queue and then have Node.js executed whenever anything triggers on that. Cloud storage for Firebase. So when files are uploaded, you can perform operations on them. Firebase hosting. So this integration allows you, when you're using Firebase static website hosting, to write proxy calls. So you can put in URL pattern matches that will redirect you to a specified cloud function. So I mentioned the API case. There we go. That allows you to take our static hosting and make it dynamic. There's also the Firebase real-time database, as you saw. And there's Firebase authentication. So when users are created, you can trigger code. So a good use case for this is, say you're storing user settings or in your real-time database, and you want to set some defaults there, Or you want to interact with a third party and say, set up a customer record in Stripe, or subscribe them to your mailing list on SendGrid. You could actually do this with that, and you can actually pull in those third-party libraries. I mentioned these were Node.js. So you can actually pull in these dependencies if they have a Node.js module available on NPM. And then there's Google Analytics for Firebase. So those great Google Analytics conversion events, you can actually listen for them and trigger code. So say a user does an in-app purchase. You could send them an FCM saying thank you, or you could write somewhere in the database marking them as a VIP customer. And there's many more coming soon. If you're interested in the additional triggers that are coming with Cloud Functions for Firebase, I recommend that you join our alpha program. So firebase.google.com/alpha. All right, so I'm asking you to take Cloud Functions to your customers. It wouldn't really be fair if I wasn't willing to embarrass myself on stage. So time for a live demo. All right, so what I've created here is actually an integration with Twilio. So, praying to the live demo gods that this will work. So let's start actually by saying hello. It wants me to send it pictures. Let's grab one from my web camera. Now let's see what it says. It's analyzing, that's promising. Awesome hair, that's what it picked up. Let's send it another one. Analyzing. Music. Cloud Vision didn't quite know what to think of Doc Brown. So how did I accomplish this? Let's show you the code. So here, I actually have my Twilio messaging callback. So what I've done here is create an HTTPS trigger, Twilio messaging callback. I glanced on this, but that is actually the root of the URL. So it'll be my Cloud Functions domain / Twilio messaging callback will actually be the URL. And that, of course, will pattern match on anything after that part. So this would be where if you were setting up an API, you could just do /API, pass in an Express application. But in this case, I'm just going to define it all here. So I have an HTTPS on request, Express.js. So this is actually a lot of this code here is just dealing with the format that Twilio is sending me the MMS in. So I'm looking at the number of pictures. If it's 0, I say, send me pictures, nom nom. Else, I'm going to create a payload because, well, maybe the MMSs were batched. Maybe it sent more than one at the same time. So I'm going to insert these into the real-time database. So here I go. I loop over them, add to this update payload, and then I insert it into the database. So I do an update, then I'm sending Twilio ML. So this is actually an XML API. And here you can actually see I have a little helper down here, send Twil ML, response type XML, send, and then the XML there. So that is actually inserting into the database. I'll actually show you where those are coming in. So there we have the inbound MMS. You can see them coming to the database. And I have a couple extra parameters here that were not for from and to and URL, which I set. So those are coming in from these pair of functions. So these functions here are independent of each other. They're running in parallel. They don't know about each other. They're isolated. So here, they're both listening to an inbound MMS push ID, and they're listening for that insert. So what this is doing is grabbing the image URL, and it's using the Cloud Vision API. So that's just an NPM module that I initialized. And it's doing label detection on those. I send it the image URI in the format that the API wants. And that's a promise. So I listen for the result of that, parse it, and then I write it to the database. So this event data admin ref. So these database writes, by default, are coming in as the user who inserted it into the database. So the Firebase real-time database rules will respect that. If I use admin ref, then it's saying I want to bypass these rules. This works in the context of Cloud Functions, where we're admin initialized. So here, I can actually bypass the rules. So my database rules, if I wanted, I could actually make it so that label annotations was actually not writable, but the admin ref would short-circuit that. And then again, so that's grabbing the label annotations. This is also a safe search annotation. So what I'm doing there is parsing whether or not it's safe for work. So if I go back to my real-time database, we have our label annotations. So music, that's where that came from. Performing arts. Performance. Well, I guess it is performing arts and a performance, right? Let's look at our safe search annotation. So it's not very likely to be adult content and unlikely to be violent. So how did we actually then send a response back to the user? So let's take a look at our code. So here we go. We're actually responding to the MMS with labels. So a isolated function. So we're listening to the database, this inbound MMS push ID, on update. So here we're not just listening for the insert. We're listening for whenever this node in the database is actually updated. So we're pulling in the current value. We're also pulling in the previous value. Label annotations. And what I'm looking for is that the label annotations are not null and that it didn't previously have label annotations. So what I'm doing there is listening for the insert of the label annotations. From and to, I put together the body, and then the Twilio client messages create to from body. And here I'm actually returning because the database ones allow for asynchronous responses. So it expects either a promise returned, hence the return the Twilio client messages create, which is the promise, or an object. That's the return null. If it doesn't return either one of these, it's going to be treated as an error condition. So that is sent by the Twilio client API, which is just an NPM library. And I actually initialize it with functions config. So there's actually runtime config that you can set so that your secrets are not in your code. So we have this safe search annotation. Where does that come into play? That's this last function here. So here I'm also listening. And what I'm looking for is, again, the insertion of the safe search annotation. It's not an update. I'm looking at the previous value. So label annotations is null, safe search null, then we're going to return null. Else, look for it being unlikely or very unlikely. If it's either one of those, it short circuits and goes back here. So then it actually writes to a public images ref. And there, I've made a static website where you can actually see these. So it's very fast to respond here. That's actually because it's through Firebase static hosting, so it's behind our global CDN. And to prove that it's static, I can actually look at the source code. And there you can actually see all those responses. So before in Firebase hosting, you couldn't have these dynamic type responses. And this is a Node application through Express. So here, I'm actually using Fastboot middleware. This is an Ember.js application. I'm putting it on matching star. And then I'm exporting app as this. And if I go to my Firebase configuration, I'm actually rewriting the entire site to go to that cloud function. So star star goes to that cloud function. All right, back to the slides.